We are going to begin our solar system today. This is one of my all-time favorite chapters in earth science, if not my favorite. But we're going to go ahead and start the solar system today. I think you guys are really going to enjoy this one as well. All right, first we're going to talk about the sun, which the sun is not a planet. It is a star, and it is the closest star to us. It does not actually have a surface. It is a large ball of gas made mostly of hydrogen and helium held together by gravity. Whoops. Here are some just questions and answers about the sun. I'm not going to go through all of this, but if you want to screenshot this page right here or this slide, you can. So you can read through it, or you can pause this video to read through it. I might include some questions on a quiz or an assignment later this week that come from this slide. So you might want to screenshot it or just pause it here and read through it. Geocentric versus heliocentric. So way back when, early scientists thought that everything in our solar system revolved around the Earth, and that's what's known as geocentric. Copernicus later proved that the sun is the center of our solar system, with all the planets revolving around it. That's heliocentric. So the sun is in the center, and all of our planets in our solar system revolve around our sun. There was a misconception way back when. Early scientists thought that everything in our solar system revolved around the Earth because they thought everything had to revolve around us. But in fact, everything revolves around the sun, including the Earth. The Earth revolves around the sun just like all the other planets. This is talking a little bit about orbits. We have day and night because the Earth rotates on its imaginary axis. So you guys all know that Earth has that imaginary axis there, and it's kind of tilted. The Earth makes one revolution around the sun in 1 year. The revolutions of planets are not circular but elliptical. We've talked about that when we learned about comets. Kepler also proved that planets seem to move faster when they are closer to the sun because of the strong pull of gravity the closer you are. All right, we're going to talk about Earth. We are at the unique position in our solar system that allows life to exist. Any closer, even just a centimeter closer to the sun or a centimeter further away from the sun, we'd either burn up and die or freeze and die. We have an atmosphere that protects us and provides us with life. We talked about the atmosphere in, I think it was January maybe, we talked about the Earth's atmosphere. We have water in all three states of matter: solids, liquids, and gases. So you have steam, you have water, and then you have ice. We have seasons due to our tilt on our axis. If it's tilted away, we are experiencing winter. And if we're tilted towards the sun, we are experiencing summer. That's why people on the opposite sides of the globe, like Australia, have opposite seasons to us in Minnesota. Our orbit is eccentric, which means that at certain times in our orbit, we are closer to the sun than at other times, but it's a very, 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 very tiny distance. All right, the inner planets. All right, again, I didn't make these PowerPoints from scratch. I got them and modified them, took some things out, added a bunch of things, so sorry about the animations there. The inner planets are also called the terrestrial planets. The terrestrial means Earth-like. These are also called the inner planets. All have a hard, rocky surface on which to land. They are closest to the sun, and some have moons, some do not. So here's Mercury, Venus, Earth, and Mars. We're going to talk about Mercury first, and we're going in order of the planets from closest to the sun to furthest away from the sun. So let's talk about Mercury first. The first mission to Mercury was by Mariner 10 in 1974. It is heavily cratered, has a very thin atmosphere made of sodium, potassium, hydrogen, and helium. And because there is not much of an atmosphere, these days are extremely hot and the nights are extremely cold. Solar winds from the sun blow away most of its atmosphere. 1 day on Mercury is the equivalent of 59 Earth days, so kind of weird. Now we're talking about Venus. The only three things Venus and Earth have in common is size, density, and mass. So I meant to take this out, but they refer to Venus as Earth's twin because it's close to Earth and it's similar in size, density, and mass, but other than that, they're very, very, very different, and Venus does not have any life on it, as we know anyway. Has retrograde rotation, which means when you view it from its north pole, it rotates clockwise. Has about 90 times more pressure at sea level compared to Earth, so you'd be really, really heavy on Venus. Atmosphere is made of carbon dioxide and sulfuric acid. Does not sound like a very pleasant place to live. Has a runaway greenhouse effect, so temperatures are very hot all the time. Again, not a very nice place to live. The Magellan Space Probe mapped the entire surface of Venus from 1990 to 1992. That was before I was even born. All right, Mars. Mars is the most studied planet in the solar system. Viking 1 and 2 in 1976 took a lot of pictures of Mars' surface and analyzed its atmosphere. Mariner 9 in the early 90s discovered 3 things. These 3 things were long channels, Olympus Mons, valleys, I'm going to try to pronounce these, Marineris. I believe a lot of these come from Latin, so I took Latin way back in middle school, so I could pronounce it in my Latin accent, but that would probably just throw you off. All right, long channels that may have carried water, Olympus Mons, so in Latin, if you have a US, it's always Olympus Mons, and then if you have something that ends in is, it's is, so Marineris. The largest shield volcano in the solar system is known as Olympus Mons, and that is located on Mars. Valles Marineris is a rift zone with past tectonic activity. It also has 2 polar ice caps of carbon dioxide, and the soils are a reddish color because of the iron contained in it. That's why Mars has that reddish glow. All right, now we're going to talk about the outer planets, which include Jupiter, Saturn, Uranus, and Neptune. We also include Pluto in this, and we'll get to that at the very end. So there's a big question whether or not Pluto is a planet. We're going to solve that today. Jupiter is, the largest planet in our solar system. It's huge. It's named after Jupiter, the Roman king of the gods. So in Roman mythology, Jupiter was the name of the Roman king of the gods. Has 67 confirmed moons. That's a lot of moons. Jupiter has the shortest days. Their days are only around 10 hours. Has a faint ring around it made of mostly dust particles. So it's kind of like Saturn, which we'll talk about next, but Saturn has those distinct rings around it. Jupiter also has rings around it. They're just very, very faint, not nearly as big and as much as Saturn's. Jupiter's Great Red Spot is an enormous storm that has been raging for over 300 years. And it's such a large storm, you could fit 2 whole Earths in it. They think it's actually shrinking, this storm, but they've been saying that for years, so we don't really know if it actually is. But this part right here is the storm, and it's huge. So anytime you see Jupiter with this iconic spot on it, know that is actually a storm. Saturn. Saturn is my favorite planet and always has been. I don't really know why. Maybe it's because it has those really distinct rings, or maybe because I remember looking at it through a telescope when I was little with my dad, but I really like Saturn. All right, in Roman mythology, Saturn was the father of Jupiter, and because they're right next to each other, even though Jupiter is much bigger, in Roman mythology, Saturn is the father of Jupiter. Its most iconic feature are its rings. So you've got these rings here, and these aren't solid rings. What they are is they're little tiny dust particles, comet particles, some bigger rock particles, ice particles, and they're moving and revolving around Saturn, which is why it looks like this nice flat ring. But it's made of chunks of ice and carbonaceous dust. Saturn has the fastest winds of any other planet in our solar system, has oval-shaped storms, which are similar to those of Jupiter. We just really can't see them as much as we can on Jupiter. And then Saturn appears that pale yellow color because its upper atmosphere contains ammonia crystals. Oops. All right, Uranus. It takes Uranus 84 Earth days to orbit the sun. It's a lot of days to just orbit the sun once. And that's because it's so far away. So the further away your planets are, the longer they take to orbit the sun. A collision may have caused the unusual tilt of Uranus. So this particular tilt is way more than any of the other planets, and I think it's because something collided into it. It is referred to as the ice giant, The upper atmosphere of water, ammonia, and methane ice crystals give Uranus its distinctive pale blue color. Super cool color. And it's the coldest planet. This also has faint rings around it. All right, is Pluto a planet? Here is your answer. According to NASA, Pluto has been officially classified as a dwarf planet. So for a while, Pluto was a planet, and then it wasn't a planet, and then they brought it back and said it was a planet, and then everyone was confused as to whether or not it actually was a planet. So officially, it is a dwarf planet. It is actually smaller than Earth's moon. It's super tiny, which is why it was brought into question in the first place. Is it even a planet if it's that small? Pluto has a thin atmosphere of nitrogen, methane, and carbon monoxide. The atmosphere has a blue tint and distinct layers of haze. It has 5 moons. Those moons must be pretty tiny, I feel like, compared to Pluto, but I'm not actually sure how big Pluto's moons are. But it has 5. It does not have rings. And it has a heart-shaped glacier that's the size of Texas and Oklahoma. This fascinating world has blue skies, spinning moons, mountains as high as the Rockies, and it snows. But the snow is red. How weird is that? When I first saw that and learned about that, I was like, what in the world? That's kind of weird. It's kind of something like you'd see on Star Wars or something like that. But this is a picture of Pluto. This is Earth, Moon, and Pluto all compared so you can see what the sizes look like. So Earth here, here's our moon, pretty big, and then Pluto's even smaller than our moon. I personally am glad Pluto is a planet again because I've always liked Pluto. He's kind of like the underdog. He's little, tiny but mighty. And it's pretty cool that it snows red there. Okay, now we're going to compare all the planets just so you can get an idea of what these sizes are. So most of us don't have any idea of the relative size of the planets and the sun, but it's rather dazzling to see it presented this way. So here's Earth. Obviously, our planet is the most gorgeous planet in my opinion. It's got the most stuff. It's the only one that can support life that we know of. And then you've got Mars, which is that super red one, Mercury here, Pluto, Venus. And then now we're going to take those planets we just looked at here and we're going to compare them to the outer planets. So let me let this go away real quick. So you have Earth at the bottom, and you can see all the inner planets, all the way down to Pluto, the really tiny one. And then you have this huge one. You've got Jupiter here, Saturn here, Neptune here, Uranus here. Look how big Jupiter is compared to Earth, or how big Saturn is compared to Earth, or even how big Neptune and Uranus are compared to Earth. And then look at Pluto. So Pluto, the smallest planet, compared to Jupiter, the largest planet in our solar system, they're so different in size, it's crazy. You could fit like a bazillion Plutos in Jupiter. Now we're going to take all of our planets in just our solar system. So the planets we learned about are just the ones in our solar system. There are much larger planets than even Jupiter that exist in other galaxies. But in our solar system, it's the biggest. But look how big our sun is compared to Jupiter, which we just saw that Jupiter is huge compared to Earth. Now let's compare the sun to Earth. So there's Earth, teeny tiny little Earth, and here's the sun. There's little teeny tiny Jupiter now. Jupiter's really not teeny tiny, but it looks teeny tiny compared to the sun. And then you've got little teeny tiny Pluto, which is like a little tiny speckle compared to the sun. Now we're going to compare our sun to this sun. So Sirius is a sun, Pollux is a sun, and Arcturus is a sun. Sirius is the brightest star in the night sky. So if you go outside and you see this really, really bright shining star, that is Sirius. But just compared to, so you've got the sun, you've got Sirius, which is way bigger than our sun. And then you've got Pollux, which is way bigger than Sirius. And then you have Arcturus. Look how big Arcturus compared to our sun is. And look, there's Jupiter. Jupiter is about 1 pixel in size compared to Arcturus. And Jupiter is our largest planet, so we can't even see Earth on here. It's not even a speckle. All right, Antares is the 15th brightest star in the sky. It is more than 1,000 light years away. So we talked about some of these stars before. I think I mentioned Betelgeuse, which is that red glowy star in the belt of Orion, the constellation Orion. Look how big Betelgeuse is compared to Arcturus, or compared to our sun, which is 1 pixel. So just look at this picture for a minute. Pretty crazy. So Betelgeuse is huge compared to our sun. Like you can't even see our sun. It's like one little dot. And then you have one that's even bigger than Betelgeuse, Antares, which is crazy. So that hopefully gives you an idea of just the vastness of our universe. Not just our solar system and planets, but our entire universe. And not just our galaxy, but just everything. It's crazy. And I'm going to have you guys do an activity that kind of gives you a better perspective of how far each planet is away from each other, and that's just in our solar system. So I'll have you guys do that activity. It might take you a little while to scroll through. You don't really have to do much work for it other than just scroll and read the little blurbs that pop up on the screen, but it's pretty cool and it puts it into perspective. All right, that's it for solar systems for the PowerPoint. The rest of the week you're going to be doing activities, including the one I just mentioned about just the relative size of our solar system and the distance between the planets later this week. So all this week you're going to be doing stuff on the solar system.